Hello, everyone. I'm Rod Alberts, and I'd like to welcome you to this edition of Queued Up Mobility. These sessions, brought to you by our good friends at Deloitte, are intended to bring you the latest news from some of the leading companies in the mobility sector. As a reminder, if you ever miss a broadcast or you want to rewatch a session, you can find them on our website at nais.com. Now let's jump into today's topic. The auto industry has been talking about electrification for more than 2 decades, with interest growing dramatically the past few years for EVs. Our panel today will discuss many market factors, including why consumers are increasingly considering EVs, the sales outlook, and OEM challenges and opportunities. Kara Clare, Senior Manager, Global Communications for Eaton's Vehicle Group, will be leading the discussion today. Kara, take it away.
Thank you, Rod, and thanks to everyone for tuning in to our panel discussion today. My name is Kara Clare, and I have the privilege of moderating an in-depth conversation with a very distinguished panel of experts on the future of electric vehicles. Joining us to discuss this increasingly important topic are Kevin Rydell, Senior Manager of Powertrain Forecasting for LMC Automotive, Julie Tolley, Co-founder and Chief Strategy Officer for Hercules Electric Vehicles, and Scott Adams, President of Eaton's e-mobility business. Welcome, Kevin, Julie, and Scott, and thank you for joining us. Electrified vehicles have been a hot topic in the automotive industry for decades, but recently the hype has begun to turn into reality. Demand for EVs is growing, driven by tightening global emission standards and technological advancements. Consumer acceptance of EVs is also increasing as vehicles are becoming more affordable and are sold in a wide array of styles and segments. While adoption varies widely across the globe, some regions are experiencing significant growth, but there are still hurdles to overcome before there is widespread adoption of electrified vehicles among consumers. And one of the top challenges facing both electrified vehicle manufacturers and suppliers is range anxiety. While today's electrified vehicles have far greater range than their predecessors, they still fall short compared to their gasoline-powered counterparts. Recharging also poses a challenge both in the lack of a recharging infrastructure and the time it takes to fully recharge a battery. Despite these and many other challenges facing manufacturers and suppliers today, we know one thing to be true: nothing drives innovation more than necessity. Tightening global emissions regulations are leading to the development of new EV technologies, next generation batteries, and a widespread recharging infrastructure. Today, we will discuss these topics and more with our panel of experts. Now, before we hear from our panelists, I want to remind everyone that we will be hosting a live Q&A session later in the program. At any time during the broadcast, you can enter a question by going to slido.com, that's SLIDO.com, and entering our event code NAIAS. I will then ask our panelists these questions, time permitting. Kevin, let's begin with you today. You have a depth of experience in market forecasting. Can you provide your thoughts on the current market outlook? What's the expectation for EV growth in the US and globally? And what are the key drivers from your perspective?
Hi, Kara. Hi, Kara. Thank you very much. And let's take a look at these issues that are happening right now. I've set up a deck to start to examine these topics.
Can't hear him.
If you could please step on.
Can you hear him?
If you could please step on to the next slide. Can you please, can you hear me now? Okay. Now, first thing that's been happening, once the president came into power, assuming the position, he really set the EPA out to reverse a lot of the policies that President Trump had worked to instill before the end of his presidency. And in fact, what they want to do now is they're working in a couple of different aspects to reverse and reallow California to the Clean Air Act for California to waiver for California to be able to allow its own CO2 emission standards, as well as to permit the ZEV regulations that it also enforces. At the same time, the EPA is also working to reverse and change the fuel economy regulations that were also enacted under that same safer, affordable, fuel efficient regulations through 2026. Now, another step to what's going on too is the California Advanced Clean Cars 2 program, currently being developed by the state of California. And that's basically going to also entail including kind of what's coming after the current ZEV, zero emission vehicle regulations, after 2026. And then we're also seeing a lot of states starting to actually think about a time when they're not going to be selling combustion cars. Rather, these cars are going to have zero emissions. Amongst the most ambitious would be Washington State's plan to only be selling zero emission vehicles by the year 2030. Next slide, please. Now, I just wanted to briefly show what the current proposal for the Advanced Clean Car Program is for California. We can see that through 2025, zero emission vehicles should make up 22% of a given manufacturer's fleet. But by 2035, that incline on the chart really does start to accelerate, leading up to a 100% vehicle fleet of zero emissions at that point. Next slide, please. From a historical perspective, we can see that the increases that in the electric BEV sales have been relatively slow and fairly consistent since 2010, when they really started first coming into the market. You can see the launch of the Model S in 2012. By 2015, most major OEMs did have some sort of battery electric vehicle on sale. However, most of these products were continued to be compliance cars, and they were only sold in California and other ZEV states as well. We really started to see the market accelerate when Tesla brought the Model 3 to launch, which really brought more of an affordability level to the market. And that's really also in 2018 when Tesla really started to dominate the battery electric vehicle market, making up 70 to 80% of battery electric vehicle sales ever since. If we take another look at this historic data in the next slide, well, we can see this gradual increase, the blue line from 2017 increasing into 2018, and the orange line 2019 in gray. So it's this steady increasing. And we can actually see that the market share of battery electric vehicle sales into the first 5 months is more than double what it was in 2020, and just under that range from 2019, back when vehicle sales were back at somewhat normal pace. So this is really happening, as Kara mentioned earlier in the opening, that there's a lot more vehicles on the market. The technology is becoming much more affordable. But we also always kind of expected 2020 to be kind of a springboard. Late 2020, early 21. That's when a lot of these new products were expected to start coming onto the market. And in my next slide, we can see a lot of these changes that were happening. And this really shows a number of these changes in one case. By the end of 2021, we expect to see a number of new brands into the market. A lot of these are startup brands, including Workhorse, Rivian, Bollinger, Lucid. Some of these are also brands that are coming from the traditional OEMs too. Hyundai bringing out the Ioniq, turning it into a brand itself, as well as GM bringing out the BrightDrop brand. But this chart really shows a lot more happening as well. We're seeing that these startups and other manufacturers are bringing out a greater variety of vehicles. Back when sales were much slower, in general, most of the products out were compact or subcompact battery electrics. And that was a segment that was just pretty much dying in sales anyway, or undergoing a continual slowdown. Whereas a lot of these vehicles that are coming out from cars, utility vehicles, pickup trucks, commercial vehicles, there's a lot of change going on, and the vehicles are being much more appealing to a wide variety of the public. If we please go to the next slide. And as a result, what we see is 2021, we really do expect to see this gradual and continual steady pace of increase coming into the market, not only as new startups coming into the market, but as well as the traditional brands bring more products into the battery electric vehicles market as well. And by 2030, we expect to see U.S. sales of about 3.3 million vehicles are going to be battery electric. And then that will make up about a 20% market share at that point. And then just to kind of show as an overlay, last month we had about 42,000 charging stations available across the US, which is been growing gradually. But President Biden's transportation plan, part of that is to expand that charging network and increase and add 500,000 new charging stations. So we should have well over 500,000 by 2030 to help support these increasing sales and that ever-growing fleet. Particularly by 2030, you figure that's going to mean there's going to be about 10 million battery electric vehicles into the fleet, and they're all going to be looking for places to charge as well. So they're trying to really bring in and make it a way to bring down that range anxiety and make that a non-issue for the general public. Now, really, this next chart shows us where the US kind of falls into place in the global scale. There's a lot of experience, a lot of growth happening in the market, but in 2021, we still expect, despite the jump in sales, that Europe is going to be selling about twice as many vehicles as we are. China will be about 3 times as many. But by 2030, with our 3.4 million of sales, we do expect that the US will make up about 10% of global battery electric vehicle sales by that point. And a lot of that is because our regulations are starting to catch up with those stronger regulations that have been acted from the European Union as well as by China. And with that, I would like to send the mic back to Kara and bring on our next panelist. Thank you.
Great. Thanks, Kevin. This is very helpful context as we think about adoption and what the EV future looks like. Julie, I'd like to come to you next. You're the co-founder and chief strategy officer for Hercules, which manufactures Hercules Alpha, a clean energy pickup. What do you think it will require for consumers to transition away from purchasing traditional gasoline and diesel-powered trucks? And maybe you can tell us a little bit about what makes the Hercules EV truck different?
Sure. Thanks so much. So I think I can't see my slide deck. I only see, sorry guys, technical. There we go. So let me just start again by introducing myself. I'm Julie Colley. I'm the Chief Strategy Officer and Chief of Staff for Hercules Electric Vehicles, and also a co-founder. Next slide. And to talk a little bit about the question you just asked, kind of kicking things off, we were founded in 2018 by James Breyer, and Greg, my colleague, and I joined as co-founders in 2019. One of the things that's unique about our founding team and makes us a little different than some of the other startups that you see is the fact that between the three of us as a founding team, we have over 100 years experience in the automotive industry. We're all automotive veterans, have been around for a long time, and understand the challenges that are faced when trying to launch a new vehicle and also a new company. We are focused on luxury eco-utility vehicles. Our first vehicle being a full-size all-electric pickup truck. The next vehicles that we're planning to launch after that are going to be an SUV, a full-size SUV. We're also looking at marine applications and other recreational vehicles that would be associated with that. When we talk a little bit about our company, another thing that we think makes us different is the fact that we're building it on 3 pillars. So we're not just focused on the environmental side of it. It's a big part of what we're doing and where we're focused. But we're looking at the entire life cycle of the process of designing and developing and manufacturing those vehicles, as well as the business as a whole. We're also focused on giving back, and we're also very focused on fiscal responsibility, which I think has been front and center recently, especially when talking about startup EV companies. So going back to the discussion around the life cycle and something else that makes us unique, as I said earlier, we think about the entire process as we're looking at developing the vehicle. So we are focused on kind of the whole idea that let's use the fewest resources possible in getting our vehicle to market, and having the least impact in whole from a manufacturing perspective. So when you talk about designing and building a brand new vehicle and even an automotive company, it's very resource intensive. We have a modular powertrain that can be used across all of our applications. We also are sharing a vehicle platform and sharing our manufacturing facilities, which allows us to utilize capacity that's already existing within the industry, and also utilize work that our platform partner has already done, enabling us to get to market as quickly as possible. Next slide, please. Oh, wait, no, I'm sorry. I'm sorry. Just going back for a moment, we also, if you talk about how we're going to market, we are planning a couple different approaches in going to market. Number one, we will be direct to consumers, so people will be able to go online and order our vehicles. But also, we've partnered with a dealer network. So we have at this point in time 35 dealers planned in the US, 3 in Canada. Our first location is actually being manufactured right now. It's under construction in Cerritos, California, and our second location is going to be in Las Vegas. So we're pretty excited about that. And again, just focusing on bringing people exactly what they want in electric mobility. So now next slide. So this is our first vehicle. It is, as I said before, a full-size, all electric pickup truck. It is focused on the luxury market. And one of the things that is unique about our design that we think sets us apart is all of our interior and exterior styling is done by Pininfarina. They're our design partner. The vehicle is basically a supercar in disguise as a truck. So it will have 1,000 horsepower. It will have a 300-mile plus range. It has 4-wheel torque vectoring. It has a highly customizable interior, which we believe customers in the luxury market will be very interested in. State-of-the-art infotainment. One of the things that is exclusive to us is our solar tonneau cover, which will actually be able to generate 19 miles of charge on a daily basis on a sunny day as people are driving their vehicle around, which actually is about half of most people's daily driving. So that charge will come free to them. We have an 8 kilowatt hour bidirectional AC inverter. So you can also power your home in this situation or the event that you need to do that. The vehicle is launching in late 2022 and it will be manufactured in the US. And from a pricing perspective, it will be comparable to the other luxury EV pickup trucks that we're seeing. So for the next slide. So at this point in time, where we are, as you know, we're a startup. So we've recently launched our Series A funding process, and we're looking at a mix of institutional and also, I guess, crowdfunding kind of applications. One of the reasons that we're kind of looking at a mix like this is because we got, as we've kind of had our website out there, a lot of our customers or potential customers have reached out to us and said, how can we invest in the company? And so going down the route of crowdfunding allows everyone to participate in the process. We have just opened and moved into our first headquarters, which we're very excited about, in Farmington Hills, Michigan. We are in the process of building our first mule vehicle, which will be drivable soon. And we're also growing the team, so we're hiring. Next slide, please. And you can check us out at a number of different locations. Our website, we're on Net Capital, which is our crowdfunding source, and also LinkedIn and Facebook. So thanks.
Thanks, Julie. Very interesting to hear about your unique strategy and your go-to-market plan. I think we're going to come back to hear a little bit more later. Scott, let's go over to you now. You've spent the bulk of your career at Eaton, over 26 years, actually 27. You've worked in Eaton's e-mobility business since its inception, and you now serve as president of the e-mobility segment. I'd like to hear your perspective on the technology and infrastructure required to support EVs. Can you talk about some of the new technologies that are either available or coming to market to help drive consumer interest in EVs? And also tell us a little bit about the work that Eaton is doing to support charging infrastructure.
For sure. Thanks, Kara. Yeah, I'll start with a quick introduction of the company. Some in the auto industry might know us, but we're a very large company, about a $20 billion a year revenue company. We can go to the next slide, and we started in the vehicle space over 100 years ago, about 110 years ago, actually. So we know vehicles. We've participated in the vehicle markets again since our inception. We made axles actually for small light trucks, was one of the first products Eaton had ever. So I come traditionally from the vehicle business, which is on the left side of this slide. But then the larger part of our company is what we call the electrical sector. We manage electric power, everything, and we provide solutions, products, systems, and solutions in the electric energy space. That could be at utilities and generation, distribution of electric power, and point of use. So everything from a breaker box that may be in your house or your apartment to large scale industrial uninterruptible power supplies that may support a data center or mission critical applications like a hospital, let's say. So when we formed our e-mobility business, we brought together elements from our traditional vehicle business with elements from our electrical sector business to really leverage the expertise across those two parts of the company. And so I'll be able to come back a little bit in a minute on your question on the infrastructure side. If we go to the next slide, just a quick overview of what we do in Eaton's e-mobility business, at least in the on-vehicle side of the equation. We participate in three pillars of products, which are in the blue boxes at the top of this slide. Power electronics, which are the onboard chargers, DC converters, and traction inverters, as well as auxiliary power inverters, not unlike what Julie had referenced. We do power distribution and circuit protection. So everything from a component that would be a fuse to larger, more sophisticated systems that go on the vehicle, protecting and distributing that high power that's distributed around the vehicle. And then particularly on the commercial vehicle side, but also on light vehicle too, we make gears and as well as transmissions that go into the vehicles. The gray boxes on the bottom, we don't produce the components that are in those systems, but certainly our products interface with them. So we make sure that we have kind of that system knowledge, if you will, to provide our products and solutions and work with our customers and other supplier partners. If we go to the next slide, I'll dive in a little bit to the question that you posed, Kara, and this links really to some of the things that Kevin and Julie talked about. We definitely see customers wanting decreased charging time. I think everybody understands your customers are accustomed to filling their gas tank. They'd like a charging experience that is either close to or potentially as fast as that. Not sure we'll ever get quite to that point. The other thing that customers want are increased range. Julie mentioned over 300 miles. We see a lot of the vehicles now kind of in that range. And my personal view is that we're going to probably see that range continue to increase as time goes on. And we'll probably see a convergence between what people are accustomed to from the range of a gasoline car or combustion engine car with an EV. So I think that march will continue as the cost of batteries come down. But the challenge is those two things on the top of the slide conflict. The bigger the battery, the longer it takes to charge. If I want to increase the charging speed and reduce the charging time, I have to put the power into the vehicle much faster, which means that charging energy is much higher. And that creates challenges for both the charging infrastructure as well as the vehicle. And that's really, where I'll come back in a minute to your question on the technologies. And then the third thing, and Kevin alluded to this, is just the variety of models. He mentioned compliance cars initially, and I think we all now know, just as consumers, even if you don't, if you're not part of the industry, you're seeing a lot more options: luxury cars, trucks, SUVs, and certainly still an element of the compliance car factor as well. So with that comes a lot of variation in terms of what the OEMs, the car companies, have to create, as well as the suppliers to support them. So if you go to the next slide, which would be my last slide, I'll just kind of highlight, some of the products and then come back to that question you asked. In the upper left is one of our traction inverters. We're really focused on making sure they're as efficient as possible and provide, peak performance based on the customer's needs. The lower left is an example of an integrated onboard charger, DC converter. Certainly power density, efficiency also is important there. And how could we make those products and integrate them in a way that is leveraging the components and to provide the different functions that they need. In the lower right is an example of a power distribution unit, so circuit protection and power distribution to the vehicle. And in the upper right is a product that we announced recently called Brake Door. If you think about it, you've never heard of a circuit breaker in a car, and yet you're accustomed to circuit breakers in your home or apartment. The reason for that is circuit breakers work on AC power. They don't work on DC power, but the power used in a vehicle primarily is DC. So we have developed a technology that acts both as a switch, like a circuit breaker, as well as a circuit protection device for DC power. And we've been awarded a production program that will launch in a couple of years and have a number of development projects with different customers around the globe. So just a quick highlight of some of the activity that Eaton has going on. So come back to the question, try to answer it quickly and hand it back to you, Kara. But so I mentioned this increased power. We want to charge faster, yet we have bigger batteries, and that charging power you have to manage it. And you have to manage it safely. So on the vehicle side, that means I've got a lot more energy coming in. I've got to manage the heat. I've got to protect that power. I mentioned, a couple safety devices already. Managing that power safely becomes much more complicated at the higher power levels. So we have created solutions like the Brake Door, as well as systems, more sophisticated ones than are shown here in the lower right, where we help customers manage that power safely, going from the charging stage, of the vehicle to then the operating stage once it's charged and, being used. On the infrastructure side, Eaton also plays on that side. And I think a lot of times people have just the EVSE or the EVSI, the charging station. But really, there's a lot that goes behind those. If you're installing a charging station, you have to think about the peak power being used if you had all of them being used at once. You have to think about the peak cost. If I'm charging vehicles in the middle of the day, I want to avoid demand charges, peak demand charges that utilities normally charge. And so you may have a charging station that uses power. So I mentioned we provide uninterruptible power supplies. That type of advanced energy storage can also be used for car charging. So we have examples where we are installing essentially energy storage systems at some DC fast chargers really across the US. And then intelligently managing the power. If you have both grid power coming in, but you also have renewables like solar, you got to manage that energy generation or energy flowing in. You want to have some of it go to the battery storage. You need to manage it to the various cars or trucks that you're charging. Managing that power intelligently, which is typically called in a microgrid system. We make the software that also manages the power both efficiently and safely. So you really see, to kind of bring home the answer to your question, Kara, we see technologies on vehicles, certainly, and then we see technologies on the infrastructure side, to manage the power to get to the point of charge. So thank you. I'll hand it back to you.
Thanks, Scott. Very good insight here about the existing technology and what's coming to market to continue to support this transition to EVs long term. And with that, we are now going to transition into our Q&A session for the remainder of our time today. As a reminder, you can submit a question at any time by going to Slido, that's slido.com, and entering our event code NAIAS. So let's get started. Julie, I think we're going to come to you for this first question.
Okay.
And sorry. So a little technical difficulty there. So for the major application segments, battery, power electronics, and e-powertrain, what will Hercules design in-house?
So we are designing our e-powertrain in-house, and we are designing it such that we can specify components that are primarily off the shelf or off the shelf with minor modifications. That is one of the ways that we're getting to market so quickly and able to launch in late 2022. There are other major systems in the vehicle that we'll be redesigning in order to handle the torque. For example, the rear suspension, and then from a, I guess, branding and styling perspective, the interior as well.
I think we're going to go back to Scott for this next question. Everyone talks about components becoming obsolete with the coming of electric vehicles, such as engines, turbos, fuel lines. What are some new components that would require new supplier panels that are coming into market?
Yeah, well, I've talked about some of them that Eaton produces. I've talked about power electronics and circuit protection. But if you broaden the scope, maybe every component to a certain degree somewhere in some industry: batteries, motors, motor drives, inverters, rectifiers, and so forth. But really, what we see in the industry is really a tailoring of those types of technologies for the vehicle markets. So while motor drives have been around forever, making a motor drive or a traction inverter that works in a vehicle that has, vibration, that has to go through very dramatic thermal cycles, that has a certain life expectancy of the end user, again, depending on the segment, that life may be different, is really where the innovation comes. And doing it obviously cost effectively, which is, it doesn't change whether it's an EV or a traditional vehicle. Cost matters in our industry. So really what I would say is what we're seeing is really a hyper focus on tailoring technologies that may exist elsewhere, but really creating unique applications of those for the vehicle markets. And then, as you know, I alluded to the one advanced technology that I had on the slide, that we have, the brake door. Think of it like a circuit breaker for DC current. That is new. We had developed that type of technology for our infrastructure, but we were kind of way ahead of the game. You don't have a DC factory; it's still AC. And then we took that technology and developed it specifically for EV cars. So I think it's the whole industry is innovating very quickly, and we're going to see continued growth and development in many different subsegments of the vehicle.
Thanks, Scott. We're going to go over to Kevin for this next one. The question is, what is the posture on hybrids of various types in the EV toolkit?
Hi, I think that really varies. It varies from OEM to OEM, as well as the region that you're selling the vehicles in. There's a focus really to go completely zero emission, but it's realized that it's going to take some time to get there. There's still a lot of development that's happening in the electrified atmosphere as well. So there's a lot of changes happening. Costs are continuing to come down. But you see some manufacturers, such as Toyota, they really want to progress and continue the rollout of their hybrid technology until battery electric vehicles and fuel cells costs come down even further. Whereas you have other manufacturers, such as General Motors, who have already stated that ideally what they want to do is transition by 2035 into all their light vehicles into a zero emission vehicle product. So it's really a lot of change. You've seen that change in China as well. The regulations were initially set up to grow the electric vehicle market specifically, but more recently, they've added some provisions that have given some greater benefits to having hybrid vehicles on sale as well, too. The U.S. takes a much more, they try to take a much more specific powertrain removal out of that, And they really realized that battery electrics are still costly, so there's some incentives there. But the U.S. doesn't care as long as you're meeting the fuel economy requirements, what type of powertrain you're using to do that and to meet those requirements in. So again, it really does vary in many cases.
Thanks, Kevin. Scott, this next question is for you. How have the companies represented here worked with utility companies to provide rebates for consumers to install charging stations or purchase EVs? If this hasn't happened, is it in the plan?
Yeah, I can speak for Eaton. I guess we do engage both at the federal level and at the state level with either different industry groups or sometimes directly with both government entities, which is where a lot of the incentives come from, as well as we do a lot of work with utilities. I would say, from our perspective, we wouldn't be the ones necessarily pushing for the rebates and so forth. But certainly Eaton is very supportive. Just being an energy management company, we're very supportive of initiatives that drive towards, a greener future. So we're active, I would say, on the the government side of that equation, engaging, in rulemaking and so forth, whether, like I said, either directly or with other industry groups. And as a consumer, I would like to see more and more of what the question was posed to. Definitely support the idea.
Julie, we're going to come back to you. You spoke about the Hercules Alpha in your comments earlier, which you expect to bring to market in 2022. Is Hercules planning to focus on the truck market, or do you anticipate developing vehicles in other segments?
We do plan to develop vehicles in other segments. So we are starting with the pickup truck, and that will be our first launch. Following that, we'll also have a full-size pickup as part of our portfolio. And then we're also looking at, like I said before, marine applications and other recreational vehicles. And those could be RVs. They might be like side-by-sides or off-road kind of vehicles. But yeah, we're looking at a number of different applications in order to utilize the platform because, as we said, it's modular. And so we can use the same powertrain design across multiple applications, just in different configurations.
Kevin, in your comments earlier, you spoke about the forecast for a strong increase in battery electric vehicles in the U.S. in the coming years. You talked about how sales in China and Europe are far ahead. Can you talk more about what's driving the difference in demand and if that may change?
As far as battery electric vehicles, we're concerned, the Trump administration really was trying to take a more pragmatic and really reduce the cost to consumers. So he really didn't try to push battery electrics, and he really didn't want to do that at the expense of government budgets as well, and putting it on the taxpayers' shoulders. In China and in Europe, it's been much more. They have a much, part of a lot of their requirements are driven by climate science. And that was something the Trump administration didn't decide to follow. So China, as well as Europe, have driven over a long time. Europe had the CO2 regulations that have been steadily getting tougher and tougher to follow, particularly for combustion vehicles. And it's getting to the point where you do need some sort of electrification to be able to meet those challenges. In China, they decided that, look, we want to become a leader in battery electric technology. So the government decided to instill their new electric vehicle program as well. So that had a very ambitious timeline to try to meet certain fleet percentages for battery electric sales. So really, those really kind of pushed those two markets to become leaders in the technologies. Whereas at that same time, again, President Trump decided to really kind of roll back a lot of that previous agenda from the Obama administration. And he just wanted to be able to say, look, manufacturers, we want you to be able to make money on what you sell what's out there, sell what the public wants. And I think, but as far as battery electric perspective, that kind of put the U.S. in a secondary position temporarily.
Thanks, Kevin. And I think we have time for one more question. And I think I will just ask all three of you to weigh in here if you have thoughts. Can you comment about how the life cycle assessment of an EV compares to that of a full mild plug-in hybrid? I hear a lot about toxic rare earth metals and challenges with battery recycling.
I could take a stab to start if you'd like, Kara. There are out there, and I think you have to be really careful about understanding where the study came from or how it was funded. But I think in the general consensus, and Kevin and Julie, if you have different thoughts or views, please weigh in a second, but is that producing, I'll just use an EV versus an ICE because it's kind of easy. The hybrids would be somewhere in the middle. But I think the general consensus is the production of a BEV, because of the battery, does use more power and emit more CO2. But over the life cycle of the vehicle, the net benefit of a BEV is very clear. And sometimes you'll get debates about, well, how was the electricity generated? Was it with coal? Was it with renewables? But even considering that, obviously, if it's renewables, it's a lot better than if it's coal. But even considering that over the normal life cycle, a BEV ultimately is better for the environment. Now, on the certainly there are metals like particularly cobalt that are in batteries, and even how cobalt's mined is even a humanitarian concern, which is an issue that has to be dealt with. And certainly the battery companies are trying to reduce cobalt or completely eliminate cobalt. That helps solve both a cost and a humanitarian issue. Kevin and Julie?
I think if you also look at from the European market as well, recycling has always been very important. And once a vehicle reaches end of life, there's an expected amount, certain percentage of it that you're expected to be able to recycle. I think battery is going to become a very important part of that. And I think that there's going to be a lot of work done towards recycling, particularly as we continue to need more and more resources, be able to build more batteries. Gigawatt hours of energy capacity are going to be needed in the coming years as well. So I think there's going to be a big focus on increasing recyclability and being able to recoup some of those elements as well to be able to give them a second use into the marketplace and into our vehicles.
Yeah, and just to kind of piggyback on what Kevin was talking about, as an OEM, when we look at our battery pack and the useful life within a vehicle, we're also looking at what can you do with it at the end of its life within the vehicle, because it's not done completely. It's not something that you would just throw away at that point in time. You can use it in other applications. So when you think about the way we're looking at our modularity, we can take that battery pack that's at the end of its useful life in the truck, and then we can use it maybe in a marine application or for other applications that might not even be tied to our business. And then after that, at the complete end of the life, we are also looking at recycling alternatives and the appropriate way to dispose of the battery when it's done.
Great. Well, unfortunately, that's all the time we have for today. I feel like our conversation could go on for at least another hour, so maybe we'll connect back again in the future. I want to thank our panelists for providing their perspectives on the electrified future of the automotive industry, and thank you to everyone who joined us today. Back to you, Rod.
Great content today, Kara. Thanks for leading the conversation. I would also like to thank all of our panelists for taking the time to share their thoughts with us. There's so much happening in the EV industry. Panels like this definitely help us keep on top of the market. As I said earlier, if you missed any part of this broadcast or want to rewatch prior broadcasts, simply go to the NAIS website. That's all we have for today. I appreciate you sharing your time with us and look forward to speaking with you during our next broadcast in July.